is on the really bleeding edge with respect to data analytics and predictive modeling, and he's always looking at things differently. Further, he believes that the two-year graduate has a place in all of these fields. And this is very interesting because especially in data science, they seem to think that most employers seem to think you have to have a master's degree. Take it away.
So let me get into it and elicit your responses, your feedback to this slide. There's a confusion matrix out there. When I say artificial intelligence, a lot of folks might say these words. A lot of times an artificial intelligence engineer is said, or they mean data engineering, or they actually mean computer programmer, or they mean a risk analyst. So is there any word, name, title up there that resonates with you and what you're teaching your students or not? Or is there one that's missing? Is there one that you have a question about? This is going to be very interactive. So, and unfortunately, I can see your names, so I might call on you if I don't get a question from the audience.
I think they all apply.
Yeah, so they all apply, right? So these are all jobs that are out there. And so how in the world does a community college, much less university, much less any individual, develop a curriculum or develop themselves to be one, two, or more of these things? It's almost an impossible task. I was talking with the director of the analytics program in South Carolina yesterday. And as she and I were talking, she had a hiring manager approach her, and she said, well, why would I ever care about certification? Why would I ever care about degrees if I can just go and look at somebody's GitHub and see what code they post? And I was mad about that yesterday, but as I went out on my run this morning, I don't know if it was the cold and the snow around me, but I was furious about it this morning. I was absolutely furious because I would love to go back, and I think I might, call up that hiring manager that's out there. And I have no equity or position or worry about it, but I really want to talk with him or her and ask the question, why the heck would they say that? Are they really reviewing the GitHub of your college graduates? Are they doing it? And if they are handing it off to somebody else to review the GitHub and to review the code and to consider the statistics, well, I have no time to talk to them because they're not really doing it, are they? And there's all sorts of bias that can come into play. So what code is the right code? What formulation is the right formulation? What's to say someone else's creativity for approaching a solution is not theirs? Give me a thesis instead. Give me somebody who can present and talk, and I'll show you a more qualified data scientist. So again, certificates in any single one of these, I don't know if they matter a whole lot to me. Neither do huge, vast repositories of GitHub. And so it just makes it even more confusing to how we hire and find the talent that we will need that Matt was talking about during his presentation. Matt, really loved your presentation. So the confusion matrix continues. Here are some charts that I pulled. This one's from Gartner. If we look at what they're talking about when Gartner says data analyst, machine learning engineer, data engineer, and data science. So it comes up with different things, right? The very important, the less important, the data wrangling, the software engineering, the data visualization and communication. So is this how we should teach the curriculum? Is there time in a 2-year curriculum for teaching any of those under any of those columns? What are your thoughts? Some of you educators out there, if I were to show you this and tell you to develop a 2-year curriculum, how would you feel?
Confused.
Yeah, confused.
Where do I start? Where do I begin? Yeah.
Where do you begin? Absolutely. Okay. All right. So we're gonna sail along here because absolutely, you're getting the point. There's a confusion matrix. Where do we start? And this is nothing new. You guys have been asking Anne this, and she's been guiding us to the more promised land. And so let's talk about what's in AI. So having recently joined ECS, I'm developing our AI program, and I've broken it up into chapters and sections. And I've called it here Communities of Practice and Business Applications. And so it's interesting. I was talking with a colleague yesterday as I was reviewing the plan, the program, the strategy. He said, well, what's interesting is on this plan, on this roadmap, and there's another slide where I talk about big bets. He said, I don't see any AI anywhere. And I said, well, what does AI mean to you? And he said, well, neural networks and everything else like that. Okay, and how are those neural networks formulated? What do they rely on? What do they do? And so whether you're talking about, and when everyone says AI, they immediately say neural net. Not, explain to me the difference between an RNN and a CNN. And there are a few people that can do that, probably on this call, and even fewer people in government. So explain for me the difference. Tell me the difference between AGN and ANI. And tell me how these things permeate together. So folks, when I say blue collar AI, I mean a distribution of AI skills across these communities of practice. As you develop your AI program or your feeder to an AI program, yes, there will always be a PhD. Yes, there will always be a master who use their education and their experience to be the leader in that program. And I think that comes from folks who go to community colleges, onto universities, onto PhD programs, and then have opportunities to lead programs as vice presidents and CAOs or whatever have you. But for every CAO, there is an army, even a legion of other kinds of data science specialists, right? If we think about your local high school, I was thinking about this late last night. Think about for every superintendent, how many bus drivers are there? How many lunch ladies are there? How many janitors are there, right? There are these blue collar supports that make that ecosystem of a school operate. And so is the same with AI. Not everybody is going to come out and be the Elon Musk. Elon Musk has an army, or has armies of armies that support him from the bottom up. And so what I want to suggest you do is you look at this list of the things on the left-hand side, communities of practice, and circle those ones that you think can be taught during a 2-year program, and select maybe 2 or 3 that you want your community college to specialize in. Perhaps Anne can help us do like a lottery. So everybody's not doubling and tripling up on the same thing, right? There can only be 3 in automation. There can only be 3 in computer vision. There can only be 3 in data blending. As a built community, that sort of distribution and synergy would be brilliant. But what I want to suggest is automation, computer vision, data blending. That sort of focused speciality can absolutely be taught in a 2-year program. It can be very discrete. It can be very focused. And then that graduate goes out, and she or he apply to a program, and they have a tool, they have a skill that can actually plug in to a greater vision that the company is doing. I'll speak to some of the things that we're doing at DataPrime. We are doing an awful lot with regards to human factors, with regard to optimization, with regard to data operations and visualization. Give me a highly qualified 2-year college graduate or community college graduate, and I can have them a job adding to my team. I don't necessarily need, or can I afford, the folks coming out with masters. And then on the right-hand side, what you could do is you could look at those business applications, and you can say, okay, if my college located close to folks who can sponsor capstone projects or internships, where that person who learns automation can go have a meaningful experience in pricing and promotion, because that a cat or dog is going to be immediately hireable, marketable to those companies that focus in price and promotion optimization, right? So you're putting 2 discrete things together to make that person marketable. And that's not very white collar. And I think we would agree, it's not white collar. It's not an Elon Musk. It's not a vice president. No one's getting hired at school as a vice president, but they are getting hired out of school to do a specific task, especially like data labeling, especially like automation engineering, especially like data engineering. Those 3 especially. So I'll pause there and see if anyone wants to push against me on this, or if they want to go rah. Any thoughts?
Would this be a gig person using their specialty, or a full-time person with the company?
That's a great question. I think what we're seeing in the future of work is there's an awful lot of contract to hire. At my own company, I've noticed that we are starting to favor some contract to hire 3-month contracts before we bring them on full time. In my company in ECS in the government space, we are offering full-time employment gigs, but these persons, namely need to come out with a clearance, or they need to be clearable and with a particular niche. So I think it depends, right? I think we're going to see things continue to evolve in the future of work. I think we're going to see more of a gig economy, good, bad, or indifferent, but I think it's both.
Aaron, this is Glenn. I really like what you're showing on the screen right now. And the one thing that I think would be valuable to the educators and definitely the students would be if, as you mentioned, the one with pricing and promotion, which skill set tied to that, is if we could find a way to take those communities of practice and then build out what are the functionalities, business applications they apply to specifically, and then in what industry do they occur, so that the colleges could go out and say, well, we have a strong presence in Dayton, Ohio for Sinclair Community College of this type of business application. So we should focus more on those areas to serve the community in the word community college.
Yeah. If you're looking for a pricing and promotion data visualizer, we are the college to come and get them from, right? We are the feeder school. And there's so many permutations of these communities of practice and business applications. It should be hunting season.
So Aaron, there is a comment there's a college in Wisconsin saying at this college, we can only develop a degree if local industry believes and would hire these people. And it's very hard to get industry buy-in with a 2-year degree in this space.
Yeah, I agree with you. It is hard to get industry buy-in. I am actually facing that same hurdle right now. I'm a proponent, like Ann said, because if we are going to have the scale of workforce that we need to confront the challenge of China and other Eastern countries, we have to do more with more people faster. And we're going to have to stop being such snobs and assuming that only a person with a master's can do this work. It's interesting in the government, there's some programs, I'm not going to enumerate them now, but there are some programs that are being stood up because there is such a lack of clear data science professionals. They are taking people who have light analyst skills and are giving them some of these Udacity, Coursera, other courses for them to pick up and become a minimum viable data scientist. That is less than or equal to anything they would pick up at a community college. I would say even far less than anything they would pick up at a community college. So flip that. Instead of people getting on the job, reskilling and upskilling in place, how can the community colleges, one, produce the future workforce that comes already made for that? Or two, how can they partner with some of those employers to offer some upskilling programs for that future of work or for that upskilling of employees? So let me go on to the next slide and talk about, here's an example. We say machine learning, and this is this is a favorite graphic of mine, a hyperven. If you look, what's in machine learning? When people say machine learning, what are all the kind of career paths and title and position descriptions that are out there? It's a blend of mathematics, programming, business, and communication. But you can see that as it all comes together, you can have a machine learning lead or a data scientist or a typical machine learning engineer. And then you get management and programming and marketing and how it all blends together. So what I want to say is, it's like Baskin Robbins. There are many flavors of machine learning engineers. What are the ones that your program is going to focus on and develop? In a 2-year program, perhaps the mathematics cannot be quite as deep as you like. So does that mean you focus on the communication, the business, and the programming? And if you are focusing on the communication, the business, and programming outside of the mathematic circle, perhaps you're right over here, right? So you can start to see what are the strengths, what is viable, and how can I overlay that? And I would say you could develop a similar view for machine learning on through all of those other communities of practice that I had listed there. With more time, I might have done that. I have only 3 more slides. I'm going to tell you a tale of 2 atoms. It's funny. I first saw this. I took a screenshot of it off of Facebook, and I'm not on Facebook very often at all. But I saw this pop up, and it really resonated with me because someone on Facebook was essentially saying the same things that you are, right? That someone can go to school, get a bachelor's degree, and pay $100,000 in student debt, and they can't find a data science job after school. And they believe people without college degrees are stupid. But somebody else can go to college, perhaps a community college, and get a 4-year paid apprenticeship, come out with no debt. You begin earning immediately $80,000. I don't think there is a data science job that I know of in my past 3 companies that are paying less than $65,000. So we'll say $65,000 to $90,000. No student debt. And guess what? He's disconnecting the other atom's electricity, right? Or he is doing the job that other atom wish he could have in terms of data engineering. So that data scientist atom comes out with $100,000 in debt. He got a bachelor's, or maybe he went on and got his master's too. He's got $200,000 in debt, and he can't compete or get a job. And yet that other person who came out with a focused degree on data engineering, on data visualization or automation, he or she are already working, getting paid, 70 and working themselves up to 80 along the way. And so that's what I mean by farmers, miners, and welders. So let's talk about these clowns, the people who threaten national security and what we need to be doing, and national security, national prosperity. So the greatest threat that you or most employers have are the undisciplined, the uncredentialed, and the ungoverned. So when I say zombies, pirates, and clowns in the field of data science, I have met these people, or I've met the personification of a zombie. The personification of a zombie in data science is somebody who literally comes over with a Bachelor of Arts or an MBA, and they decide that they just wish to cannibalize the great work or the engineering or the visualization that you've done and apply it to a business problem. Let me help you translate that. And they just eat the brains of the true operation like a zombie does. The pirate are the folks that will come and jump onto your analytics project. You think you're sailing to a great analytics outcome, and they all of a sudden commandeer the ship and they steer it to an entirely different outcome. And these pirates oftentimes are called MBAs or bucks just out of college. They spell certain doom for data science as well. And then the ungoverned, I like to talk about this, especially where AI ethics councils, they're alive and well in both my companies, and they're actually imperatives across most companies. And as a matter of fact, if you haven't done this at your college, I would consider, perhaps something that Matt, Glenn, and I, and Ann and others could talk about too, is how does every community college start an AI or data ethics council? That might be a really low-hanging fruit that you can get started with and start to distinguish yourself as a community college with. So it's the folks who are ungoverned, that aren't asking about what they are doing with their data, or aren't asking about what's happening with their algorithms, or aren't asking about what data dictionaries and analytics dictionaries and products mean. And those folks also spell certain gloom. And so that's the greatest challenge. Our greatest hope is actually what I call the blue collar AI, the blue collar jobs that are out there. I listed them earlier as a communities of practice, and there were like, 12, 13 there. But if I were to distill them to 3, I think all of those on the framework community practice fit into one of these buckets. They are the data farmers, the data miners, and the data welders. And let me explain what I mean by each one of those. A data farmer is somebody who helps cultivate the data, who perhaps helps label the data, who helps wrangle the data, right? The typical farmhand jobs that we think about with livestock is what's happening with our data today and how we grow that field of blue collar AI for those hyper data specialists. We'll never not need an actual farmer, and we'll never not need a data farmer too. Data miners, these are, just like miners in the true sense of the word, the folks who can go in there and extract the ore and find the gem and surface it. Doing that kind of work is so important these days as we're working to find the data within the data, discover and develop metadata programs, to bring in open source data, to develop, to work with publicly available information or open source intelligence. Data miners is enormous. Not only in the DoD, you can think, when I say open source intelligence, OSINT or PAI, publicly available information, certainly the government has a whole bunch of things like that we need for that, as you saw with the recent arrests of those rioters in Capitol Hill. But also you can think about turning that into commercial use and what that means for just customer activation. Right? So data miners, the need is a many. And then finally, welders. So just like the persons who can join 2 pieces of metal together and have them bend or twist or remain taut forever, and that same kind of person is needed for the data operations to have it fully connect with the business case, creating the data pipelines, creating the sort of data applications or the disconnected applications, as Matt was talking about earlier. That person who can connect the data and the programming to an actual business outcome is the welder, the person that delivers the impact. So for me, what's old is new again. What the community colleges and how our universities should be working together is not new or really novel. It's just the lens through which we ought to be looking at how we approach the new sense of agriculture, the new sense of mining, and the new sense of industrializing, which is data farming, data mining, data welding. So with that, thank you for your time. I hope it wasn't too abstract. I hope you got the spirit of what I was saying, and I'll take any and all of your questions now or later.